There is one other type of problem that we work on in this section. Up until this point, we have been finding the area under the standard normal distribution curve for problems where they give us the z-score. Now we're going to do the opposite. These problems will give us the area, and our job is going to be to find the z-score. So we'll begin with this example. They give us a picture and they tell us to find the z-score that corresponds to the given area. So we know that the area between 0 and some z-score is equal to 0.4066. And our job is to figure out what this z-score is. So this first problem is perhaps our easiest scenario because they have shaded the section of the curve between 0 and z. And remember that that's exactly the section that our table is designed to address, the part from 0 to the number that we look up. So in this first case, the only thing I need to do is go to my table and look up an area of 0.4066. You do need to remember that the areas are found in the middle of the table. And so when we look up 4066, we are looking for it in the middle of the table, not down the side and across the top. Okay, so if you look, we can see that our area, 0.4066, lies here. And so what I need to do is figure out the z-score that goes with that. So I'm going to come off to the side here, and I can see that that z-score starts with 1.3. And then I'm going to go up to the top and note that the hundredths place digit is a 2. The only other thing that I would want to check is whether that z-score is positive or negative. But because my z-value line is on the right side of 0, then it's going to be positive. And so that z-score will be 1.32. Our next example gives us a picture where we have shaded to the left of a z-score. Here's our z-score, and we're shading to the left of it. And they tell us that the area is 0.9671. Now, this problem is a little more involved than the first one. Remember that in this scenario, that 0.9671 comes from adding the two pieces of the curve together. So what I want to do is break that up back into those two separate pieces. So I know that the area from the 0 line all the way back is 0.5. All right, so do we agree with that? We can tell that because we know that the entire left-hand side of the curve is shaded. Therefore, that area is 0.5. Now, the next thing I need to do is figure out what this part is. Now, remember, to get the 9671, you added 0.5 and whatever this was, and together those two pieces made 9671. So I could come off to the side, and if you need to, you could subtract the 9671 minus the 0.5, and that would give you 4671. So 4671 would be this area. Okay, so again, we want to make sure that that makes sense to you. That if you have these two pieces, that together they make the total of 9671. Now, the reason that I needed to break it up, remember, is that the table only works for looking up a number from 0 to z. So if I'm going to use my table to look up an area, I have to have this part right here. Okay? So I'm going to now go to my table and I'm going to look for 0.4671. Okay. And so you may not be able to see it on the screen, but if you look at your paper table, you're going to see that 4671 is sitting right about here. All right, and if you come over, you can see that that lines up with a z-score that begins with 1.8. And if you come up, you're at a hundredth place of 0.04. So our z-score is 1.84. Now again, you need to make sure that it should be positive or negative, but because your z is on the right-hand side of 0, it'll stay positive. All right, let's try one more example. So this example has the area of 0.0239, and it is referring to the part in the right tail of the curve. Now, again, remember that the only way you can use this table is to look up the area from 0 to the z. So oftentimes students will come into a problem like this and they will go immediately to the table to look up 0.0239. But remember that the table, the only thing you can look up in the table is from 0 to z. So I have to work on this number first before I can go to the table. So how could we find the area from 0 to z? What do we know? We know that the entire right-hand side of the curve is going to be 0.5. So if I take 0.5, which again is the entire right-hand side, and I take off the 0.0239, so I'm going to subtract that off, that is going to leave me 4761. Okay, so 4761 is this part right here. Now again, you want to think about that and make sure that that makes sense to you. I know that these two pieces together make up the entire right-hand side of the curve. So these two pieces together should be 0.5. So I'm going to take that total of 0.5, I'm going to subtract off the part that I don't want, should leave me the 4761. Okay, so now I'm going to go to my table and I'm going to look for the 4761. All right, so you can see that that is right about here. Now I'm going to go to my paper table and look it up. 4761 is going to be a z-score of 1.9 coming across. And then if I go up to the top, I'm going to be at the 100th place of an 8. And so again, you want to check and make sure that that's a positive z-score, which it is because it's lying on the right-hand side of 0. If it had been on the left, I would simply put a negative on that z-score. The last thing I want to share with you are just a couple of helpful hints to think about as you work some of these problems. Note that your table doesn't contain every possible area. So sometimes you will be working a problem and you'll need to look up an area that is not in the table. So we have two rules that we use for that. So the first one says that if your area is not in the table, you should use the area that is the closest to the one that you need. So just as a quick example, if you had a picture of a curve and we'll do an easy part. We'll just do this part right here that's shaded. And they told you that that area was 4720. Now I don't need to do anything to that area because it is the correct part of the curve from 0 to z, so I'm simply going to go look that up. But when I go to look it up, I see that my table has 4719, and then the next z-score, the next area is 4726. But there is no 4720. And so the rule is that you're going to go with the closest one to the one that you need. So 4719 is closer than 4726. And so I'll use 4719 and read off that z-score as 1.91. The other possibility is if you're looking up an area and it's not in the table, and yet it's not necessarily closer to one number or the other. All right, so let me show you one of those. What if we had the same section, but they told us that the area was 4500? And so we go into the middle of our table looking for 4500, and we see 4495. And then the next one in our table is 4505. And so if you note, the 4500 is going to sit right in the middle between those two areas, and it's not going to be closer to either one. In that case, we are told to use the larger. There's no reason other than the fact that at some point a statistician decided that's what we would do. All right, so 4505 corresponds to a z-score of 1.65. And that would be our answer in this case.